Alright, so my name is Ira Kemelmacher. I'm going to teach computer vision. It's going to be in spring 576, CSE and EE. So let's see. So what is computer vision? Just to make sure we're on the same page. So basically we have all these devices now, mobile phones with cameras, all sorts of cameras, even devices that can capture depth, like Kinect. And all of us capture millions of photos and videos and every day. And so computer vision is all about coming up with automatic methods, algorithms, to be able to analyze this visual data, images, videos, depth information, and so on. And the problems are how to reconstruct 3D shapes from images, videos, how to recognize objects, people, faces, estimate motion, and all sorts of problems in this space. So let me show you some example computer vision systems that work to give it a taste. So for example, face detection, that works pretty well in most cameras now, basically putting a square around each face. For cameras, it's pretty useful for focusing, cropping, and so on. So this is an example problem of vision, which was solved. Face recognition, here's Google's Picasso, and my face was recognized in my personal photos, so that works pretty well. Motion capture from so Kinect, Microsoft Xbox Kinect can produce depth data, and there are computer vision algorithms that can analyze whatever the person is doing based on the captured depth, analyze the activity, and then people can play games and so on using their bodies. And here's an example, another example of computer vision method which is very successful is how can we take tourist photos, just photos that people go and take pictures of the Colosseum, for example, in Rome, and reconstruct 3D structures of the Colosseum, for example. So we can. It was actually developed in our lab here, and this is an example of the Colosseum inside Google Maps. So people can actually now browse, maybe many of you did, the maps in 3D and see the buildings. And here's also the Allen Center, where you see it now, in 3D. Object recognition, of course, we want to snap pictures with our phone and be able to recognize the scenes, be able to get information about what, some extra information about what we see. This is becoming real. And so in the course, we'll go over, we'll kind of make an introduction to different methods in computer vision, feature detection, how to do segmentation of objects and images, motion estimation, how to reconstruct 3D shapes from images, which are 2D data, object recognition, and so on. Let's see, some general info. I will assume that you guys are pretty good with data structures, C, C++ programming, linear algebra, and vector calculus. I will not assume that you know anything about computer vision or image processing or anything related to processing of images. And you will have really hands-on experience with the algorithms so the course will be about, we'll have 4 projects. Each of them will be implementation of different algorithms in vision. Some examples. This is an example from previous years, what students produced. Panorama, basically taking many pictures and stitching them automatically together to produce a nice panorama. And face detection, so putting squares around all the people. And I'll finish with a nice video from a series. Let's see, it works. 1 second. From CSI, which actually, okay, so the resolution will be a little bad, but it actually showcases the technology that was developed here in our lab. It's called photosynth. And just
oh, yes.
kind of illustrate what computer vision can do as well.
Photosynth. Yes, taking a large collection of photos, analyzing the similarities, and displaying them in a reconstructed three-dimensional space.
Exactly. Build me a high school gym.
Okay.
Pretty
cool, huh?
The clarity is unbelievable.
And in 3D.
Well done. So we know that Robert Greggs introduced the president at 10:18. The question is, where did he go after that and with whom? Can you zoom into the crowd on the other side of the platform? There you go, over there. Rotate it 90 degrees. Hold on, go to the left. No, a little more. Go wide. A little bit more. Go in. There. Right there. Zoom in on that door. A little bit more.
That's her vacating at the side door.
Right.
Zoom in a little closer. There's someone in front of him.
So, I'll stop it here. And you'll get no answer. You'll come to the curse. Do you have any questions?